So here we are going to implement decoder 224 using Verilog HDL. HDL stands Hardware Description Language. That means through a language, here we describe our hardware. And right now, what our hardware is? Our hardware is decoder 224. So we just try to implement this decoder 224 in Verilog. So for that, here we are using a data flow modeling style where we write the equations, the Boolean equations, but in case of your Verilog language. So let's go with this. So here we are using IC, that Xilinx 13.7. So how to start this particular platform or Xilinx? So initially, right now, on the top side of this tab or this window, there is nothing is mentioned. That means only IC project navigator is given. So first of all, here you have to create your project. Once you create your project, here you are getting the path. So let's start with this. Go in the file, new project. Right now, here you have to provide the locations where your file will be saved. So let's go with, here we are going to start on the desktop. We are having that on desktop. We may hear that we make a new folder, or already we are having that ECD lab. So we choose here ECD lab, in which we make it a new folder, that is Verilog experiments. So this location here we are providing. Okay, now we are giving here that project name. So let here we are saying that these projects are totally related with your Verilog. So we are taking that Verilog, same name we are giving here, Verilog underscore exp. These all experiments are Verilog based. Now top level source type should be HDL. Go for next. This is a particular setting about your the board where you dump your code, that is of your FPGA board. So we may have that various families. Let us assume we are going with Spartan 6. Which device we are going to choose here, that is given here. If we are taking that XE6SLX25T, with respect to what the device you are having, that particular board, then package, here speed, let with that -3. Now synthesis tool, this is very important. It should be VHDL or Verilog. And the simulator, we are going to choose here IC. Preferred language, Verilog. Next. So here you are getting a project summary. Finish. So you may find here it gives you the path where your project is saved. Now what next is, here you have to create your own file of your Verilog file, we can say. So either you can go in the project, or we are having a design view. Here you can find in hierarchy there is an empty view. So either you can right click here. So go in that new source. So in Verilog, we have to choose that Verilog module for your design. And if you are going for a simulation, so that times we have to use that Verilog test fixture. So right now we are taking up that Verilog module. So give that Verilog module name as decoder 224. Now the name should be right. The name should be start with that alphabet. It may allow the underscore, but two underscore cannot become consecutively. Where we can use that numeric number also. That means alphanumeric is considered, but it should be started with that alphabet, not number. Next. So what are the inputs and outputs? So how we can decide? So we are having these block diagrams. So here you can find your inputs are A, B, where the outputs are. The alphabet or the variable name is same, but it has index, various index, that 3, 2, 1, 0. So we are providing arranged. That means we can consider a group of 4 lines or 4 wires, that is known as bus. So here ports are, you can take that A comma B, either you can write A comma B, or you can say that in first row A, second row B. This is the input, then Y is the output, direction should be changed, output, and here you have to click bus where the MSB should be 3 because we are having a 4 line. So 3 down to 0, go next, finish. Xilinx gives you the one of the good thing that it creates a model. Now what is meant by model? Model is nothing but your we can say a black box where we are going to design. Just like here we are having a block diagrams that decoder 2 to 4. So when we are seeing a model is nothing but here that top level entity, or we can say a black box where it has the ports, some of your input ports, some of your output ports, what inside in it that we are going to design in that particular model. Just like if you are providing the gift to your friend, so what here we are doing, we are just opening the box, we put our gift and we close the box. So in the Verilog also we start with a model, that means we open the box, we have to design it, that means we put our gift, and at the end we have to close that box, that means we have to use their end model. So here you can find it start with a model, we have to write here something for design, and there is an end model. So what here model, model name, and there is a port declaration and definitions inside it, it is given. Now with respect to your Boolean equations, what your Boolean equations are, y of 0 is a bar b bar, y1 is a bar b, y2 is a b bar, and y3 is a b. So in the same way here you have to write the equations. So how we can write? So we can start with that y of 0, y of 0, note here the square place we have used, y of 0 equals to a bar b bar, a bar b bar. So how we can write a bar? So we have to write that not of a ampersand for ANDing operation, b bar, end with semicolon. Now what happened in that Verilog, a bar and b bar, this is evaluated and this value should be assigned to y of 0. So for data flow or for confidence statements in Verilog, we have to write, there is a keyword that known as assign. So this is our first statement. That means we just represent our Boolean equation in terms of data flow statements. So here we are having that 4 outputs. So we are going to write that 4 statements. Now the second one is y of 1. What is that? A bar b. Third one is y of 2. A b bar, and y of 3. A b. We just keep the base as it is. So this is simply a Verilog program or Verilog code for decoder 2 to 4. Now after that we have to save it. So when you are going to synthesize, that means we are going to check the syntax and we make it compile. So you should note, whenever we are having the file inside in this project, then it should have 3 dots. That understand it is set as top model. Right now we are having a single file, so this option is disabled. So just click on this file and go in the process. We have to synthesize. So double click on synthesize. If there is no error, we are getting the green tick. If there is an error, we are getting the red cross. And if there is a warning, so we are getting the triangle with exclamation sign. Here we are getting a green tick. It means there is no error. So we just check it RTL schematic. RTL understand register transfer level. So double click on this, go to OK. So we find it. If you double click inside it, so you are finding what the structure. how it is made 2 to 4. We have just written here that the 4 equations, and we are getting that 4 AND gate with respect to a bar, b bar, a bar, b, a, b bar, and a, b. So it is simply a RTL schematic. You can take a print screen for this. So we are going with that print preview. And you can take a snapshot by print screen options. Go in the paint, just copy it, close this. Right now we have to simulate. Now we are having two options for the simulation. One is of your test bench and second is of your direct. So for simulation, when we are going to design, it is on implementation view, and when we are going for simulation, click on simulation view. Right now we are not having any test bench, so we are just doing directly. So just click on your file decoder2_4, click on ISM simulator plus. So we are having that behavioral check syntax and simulate behavioral model. So double click on simulate behavioral model. The another window will be open for your waveform, where you will find that input and outputs. So you can provide their input, run for specified time, and you are getting that particular output with respect to your input. So here the inputs are A, B, outputs are Y3 to Y0. So just right click, how we can provide the inputs. Right click on A, go in that force constant, or either you can provide that force clock also, no problems. If you are going for that force clock, that becomes 1010 with respect to your particular durations, or force constant. So for constant, if you provide the first value is 0, A is 0, B is 0, run for specified time, that is 1 microseconds, and you can zoom to full. Right now what here, if we are putting that A and B are 0 0, so y of 0 is 1. As per our truth table, we are getting the first line, y of 0 becomes 1. Now what here the second option is 0 1, so that means we are making that B is 1. Run for specified time, zoom to full view. Now check it. What here, y of 1 is 1, remaining all are 0. Let's go for the third option, that is 1 0. So B is 0, A is 1, run for specified time, zoom to full view. You may find for 1 0, y of 2 becomes 1, and what the last one is for 1 1. A is 1, B is also 1. Run for specified time, zoom to full view. So here we check all the options for 0 0, 0 1, 1 0, and 1 1. Now what here, at every times we have to provide the value. So how we can reduce our efforts, and for that the very efficient way is to write a test bench. So let's go with that test bench. So we just close this waveform window, we go back to your Xilinx. Then how we can write that test bench? So again, either you can have a design in which we are having a hierarchy or view. Right click, you can go with that new source, or either you can go with that project new source. So let's go with that new source. As already I told you, for design we are having a Verilog model, and when we are going to simulate, we are having that Verilog test fixture, that is for your test bench. So just here we are selecting Verilog test fixture. Let's take the file name is tb, that is for test bench underscore your design name. What your design name is? Decoder 2_4. Next we are going to write the test bench for decoder 2 to 4, that is our main design. Next, finish. So by default the Xilinx provides you a test bench, okay, with their particular register A, that is for your inputs, Y is of your outputs, and here it is a very important, that means for what we are going to write the test bench, that design is instantiate. That means already we have designed it, So the same design we use in this test bench, that's why it is known as modules. Module understand the top level design where we are designing it, and the modules is nothing but where we access this design in another module. So it start with that initial begin. Here just provide that the different values of your A, B. So let's take that the first value is one tick B. What is of your one tick B? One understand the number of bits, B understand the base. Right now B here is a binary and 0 is nothing but the actual number. So in the same way we are providing that for B, and we just copy paste for your 100 nanosecond. We are wait for 100 nanoseconds. So we just copy paste it and we change it the values. First is 0 0, second is 0 1, third one is 1 0, and the fourth one is 1 1. So save this file. Right now you may find here that file, the top file is tb underscore decoder 224. So just click here, go for your simulate behavioral model and try to run it. If there is no error, you will get that directly output waveforms. It is taking time. Just stop it. We check the syntax. The process control but 8. The document window is not opening. Let's check once again. The error is here. What the error you find? Inputs